Welcome back from the break, Matrix. If you've just joined us, we are assisting you with your exam prep to help with the upcoming exam. If you're someone who's constantly running out of data, then this next competition is just for you. Matrix is bringing you the hashtag WazzoWinner competition, where 2 lucky matriculants stand a chance to win 2 gigs of data. All you need to do to enter is head on over to our Facebook page and all of the details will be there. Thank you so much, Nicola, and over to you.
Thanks, Luni. 2 gigs of data, that sounds great. You should definitely enter. Okay, so let's carry on, and we're going to be looking at functions now, which of course is always going to be in every paper one that you do. So I've got the information on the first page, and then the diagram is on the next page. So let's just read through what we have here, and then we'll look at the associated diagram. Okay, so we're told that the diagram shows that we have the graphs of f of x is equal to ax squared plus bx plus c, and g of x is equal to b to the power of x plus q. So what we can see is that we have a quadratic function over here, and we have an exponential function over here with a lot of unknowns. So we don't know any of those values of a, b, c, or BQ. Okay, then we're told that A and B are the x-intercepts, E is the y-intercept, and C, with the coordinates minus 3 over 4y, is the turning point of F. So let's just have a look at that now. Okay, so here we can see we have F is that parabola, which is obviously associated with the quadratic function. It's a happy parabola, and we can see it comes down, negative gradient, turning point over here, point C, and then turning around going up. And as was explained, there's A and B over there. Those are the x-intercepts of F. Okay, let's go back. Okay, we're also told that J is the x-intercept and D is the y-intercept of G. Okay, so let's go and look at that now. So here we have G. G is this exponential function, and we can see there J is the x-intercept, and D over here is the y-intercept. Oh, and let's not forget that D over there, that's the y-intercept of the parabola. Okay, sorry, I went forward instead of back. Okay, and y equals -8 is the equation of the asymptote of G. And finally, we're told that H, which has the coordinates 1, -5, is one of the points of intersection of F and H. Oh, sorry, F and G. So there's H over there, which we can see is one point of intersection. There's another point of intersection over there. And here is the asymptote. This is the horizontal asymptote of that exponential function, and it has the equation y equals -8. Okay, let's look at the questions now. The first question is, write down the coordinates of D. So when you're asked to write down coordinates, it's probably going to be out of very few marks, possibly 1 or 2 marks only. And you don't necessarily need to show your working. You can just literally write down the coordinates. So let's have a look, go back and look at that. So D is the y-intercept of the exponential graph. So this exponential graph has been translated downwards by 8 units. So it used to have a horizontal asymptote that was the x-axis. But now the horizontal asymptote has moved all the way down to y equals -8. So if we think about what this exponential function would have looked like before it was translated down, it would have looked like that, and it would have gone through 0, 1 on, would have gone through 1 on the y-axis, which has the coordinates 0, 1. So because the whole function has been moved, translated down by 8 units, this y-intercept has also been moved down by 8 units. So instead of being 0, 1, we know that 1 minus 8 gives us -7. So therefore, the y-intercept has moved down from 1 to -7. So therefore, the coordinates of point D are 0, -7. Okay, there it is again. We're going to use the diagram for the next question. Okay, the next question says, write down the value of Q. Okay, so we were told that G of X is equal to B to the power of X plus Q. So there's Q over there, and it is equal or tells us about the horizontal asymptote of this exponential equation. So y equals q is always the equation of the horizontal asymptote. So we can see that the horizontal asymptote has the equation y equals -8. Therefore, q must also be equal to -8. Okay, so if you know the horizontal asymptote, you can definitely get that value of q. Okay, so let's move on to question 2. Question 2 says, show that A is equal to 2, B is equal to 3, and C is equal to -10. All right, so this is asking us to find the equation of the parabola effectively. So we're going to have to turn our attention to that quadratic curve. So we know that f of x is equal to ax squared plus bx plus c, and we're being asked to calculate the value of a, b, and c. Okay, so just looking at this parabola, we don't have very much information. We don't know a lot about it. We don't know the x-intercepts. We don't even know the y-intercept over there, which is e. What we do know is that this point h lies on the parabola as well as the exponential curve. And then we know the x-intercept, the x-coordinate of the turning point down over there. So we don't have very much to go on. But if you look carefully, the equation of the exponential curve was y, or g of x, is equal to b to the power of x minus 8. So we know that q is equal to -8 from the last question. And because those are the same variable, they're actually the same value. So if we can find the value of b over there, the base of the exponential equation, then we can use that same value of b over here. Okay, so we have a point that lies on the exponential curve, so we sorted to be able to find that value of b. So this point h from here, we know that when x is equal to 1, y is equal to -5. So I can sub both of those values into this equation here. So if y is equal to b to the power of x minus 8, I'm going to sub the -5 into there, and I'm going to sub the 1 into there. So therefore, -5 is equal to b to the power of 1 minus 8. I'm going to take that over to there. So I've got -5 plus 8 gives me 3 is equal to b. Okay, so I found the value of b, and I can now move my attention to both the a and the c. Okay, so I'm just going to delete that and write up here that b was equal to 3. So I can now change my equation slightly. I've got f of x is equal to ax squared plus 3x plus c. So I'm getting there. All right, I can now use the next part, or the next thing that I know is that x-coordinate of the turning point, and that is always the x coordinate is equal to minus b over 2a, and I know that b is equal to 3 now, so I can sub that into there, and of course I can sub the -3/4 into there, and I can use that to solve for a. So -3 over 4 is equal to -3 over 2a. I'm going to cross multiply over there, so I get -6a is equal to -12, multiplying across, which I can do when I've got one fraction on each side of the equal sign. So therefore, a must be equal to 2. Okay, so I've got my a. All right, so I just need one last value, and that is c. And for that, I'm going to substitute in the point that I know, which is the 1 and the -5. So again, I'm going to just erase some of that. Okay. So f of x, or let's say y rather, because we're going to sub a value of y in. Y is equal to 2x squared plus 3x plus c. And finally, I'm going to sub that into there. So -5 is equal to, and I'm going to sub that 1 into all the values of x. So it's 2 times 1 squared plus 3 times 1 plus c. So therefore, -5 is equal to, that's 2 plus 3 plus c. This gives me 5, which I'm going to take to the other side. So I'm going to have -5 minus 5 is equal to c Therefore, C is equal to negative 10. Okay, so I've now showed that A is equal to 2, B is equal to 3, and C is equal to negative 10. Okay, and let's see what the next question is. All right, we're asked to write down the range of G. Okay, so remember the range is all the y values for which that function exists. So we can see that the exponential function exists all the way down to the asymptote, and then going all the way up to plus infinity. So we can see those are the values of y for which this function exists, that exponential function. So we can write an inequality. You can use an inequality, or you could use interval notation. Either would be absolutely fine. So we can say that y is all values that are greater than negative 8. We don't include negative 8, of course, because the function never actually is equal to negative 8. It approaches that asymptote, but is never actually equal to it. Okay, the line with the equation y plus 9x is equal to negative 28 is the tangent of f at point T. Determine the coordinates of point T. Okay, so let's just think about what's going on here. We have this parabola, and there's a point T, and a tangent is touching this function f at that point T. If we look at what this line, let's get that in standard form. So we can say that it is y equals minus 9x minus 28. So we can see that the gradient of this tangent is equal to negative 9. It's very steep, negative and very steep. So it might be doing something like that, coming all the way down, obviously touching like that. So we need to figure out the coordinates of point T over there. So if we can find the gradient of f at that point by using some calculus, by doing some differentiation, we know that the derivative of f must be equal to the gradient of the tangent at that same point. So it must be equal to negative 9. Okay, so we now know that f of x, because we know a, b, and c. And the great thing about the way that they asked the last question is that even if you couldn't quite show that a was 2, b was 3, and c was negative 10, you're allowed to use those values now to get the correct function. So we have 2x squared plus 3x minus 10. We're now going to find the derivative of that, and this is a nice, easy function to find the derivative of. It's 4x plus 3. And we can now make that equal to negative 9, because the gradient of f will also be equal to negative 9 at point T. And we can solve for x. So we have 4x is equal to negative 12, which means that x is equal to negative 3. Okay, so we have the x coordinate of this point is minus 3. All we need is the y coordinate. Don't forget the y coordinate. You asked for both the x and the y coordinate. Okay, so to get the y coordinate, we're going to substitute that negative 3. And we can either substitute it into the equation of the straight line or the equation of the parabola, because obviously that's where they both, at point T, they both touch, they intersect. So we could substitute it into either the straight line or the parabola. I'm going to choose the straight line because it's a bit of an easier equation to substitute into. So I've got y plus 9 times negative 3. So I've subbed my 3 into that x over there is equal to negative 28. So this is y minus 27 is equal to minus 28. So y is equal to minus 28 plus 27, and that gives me negative 1. And that's the y coordinate of that point. Okay, let's see if we can do one last question. Okay, we're given that h of x is equal to g of x plus 8, and then we're asked to write down the inverse in the form y equals blah, blah, blah. Okay, so let's first find what h of x is equal to. So we know that g of x, if you remember, was equal to 3 to the power of x minus 8. That was the value of b, that was the value of q. So therefore, h of x must be equal to 3 to the power of x minus 8 plus 8. So obviously those disappear, so we just have that y is equal to 3 to the power of x. Okay, and when you find the inverse, if you remember, for inverses, we always swap the x and the y around. Okay, so we literally just take the x, move it into the place of the y, and take the y and put it in the place of the x. So for the inverse, we're going to have x is equal to 3 to the power of y. And here, this is where our knowledge of logs is going to come in. So we need to make y the subject of the formula. So y is going to be log base 3 of x. Okay, so that's all we're going to do on functions. I hope that was useful. And that's the end of this little segment. So I'll hand back over to Lini.
Thank you so much, Nicola. Guys, we are going to take a break. Before we do, don't forget to send us your questions and comments on WhatsApp as well as our social media pages. And don't forget to enter that competition to stand yourself a chance to win data. But then let's take a quick break and we'll see you straight after.